An acceleration vector has components a sub x is equal to negative 4.65 meters per second squared and a sub y is equal to 3.15 meters per second squared. What are the magnitude and direction of this vector using a standard angle to describe direction? So we've seen one pretty similar to this recently, so I think we can recognize that the formula we'd want to use for magnitude would just involve adding the two components as squares and then square rooting. In other words, adding in quadrature is terminology that physicists like to use. So here it is. Okay. And for this, since you're squaring, that negative doesn't wind up mattering. So really, I'm just going to put into my calculator 4.65 squared plus 3.15 squared, square rooted, and then to be legitimate on the units, I need to put them somewhere. I find it easier just to put them all at the end when you're doing kind of quadrature type of addition here, rather than having to squeeze them in and use parentheses and things like that there. So at this point, I'm ready to go ahead and calculate that number for the first part of the answer here. And the result that I get is like 5.61649, etc. I think I can just round that off to 3 significant figures of a 5.62 should be good enough for something like this, and then write the units of meters per second squared. Now, how do I do the angle? Maybe I can just jump straight into saying that the angle I'd like to calculate is going to be the inverse tangent. I always struggle a little bit first. Oops, that should be lowercase. To remember, is it y over x or x over y? But it's y over x, and one way of thinking about that is it's opposite over adjacent, and for a standard triangle, opposite is always vertical, which is y. That's usually how I remember it. Maybe there's a more clever way to remember that I don't know. But at this point, I'm going to go ahead and put into my calculator. For this, the negative is going to matter, though, because that does affect angles. So I'm going to keep that minus 4.65 here in my calculation. And then let me go to my calculator, and I get an angle of, let's see, about, I guess, minus 34.1 degrees, I will say. Okay, does that seem correct? Maybe moment of truth, right? We can check our answer. Okay, it looks like we were good on the first one, but the second one, something went wrong. Well, what went wrong there is I forgot to draw a picture of this that may have helped me to avoid that, because it turns out this angle is correct for if the y component had a value of negative 3.15 meters per second squared and the x component were a positive 4.65 meters per second squared. But instead I've got the opposite, and it's the x that is negative and the y that is positive. In other words, if I drew a quick sketch of this acceleration vector, it's kind of pointing like it's negative x. Oh, whoops, that's actually negative y, isn't it, as well? It's negative x, positive y, so it should look like this rather than the one that I just drew. As opposed to like what this angle corresponds to is a vector that's kind of pointing in the opposite direction. So if I add 180 to this number, so if I just say, okay, plus 180, right, that, it turns out, will give me like 145 point, I guess rounded off 0.9, but maybe, I don't know, to match what you can see like there, I just said, well, 3 sig figs good enough. Either one's probably fine by me, to be honest, but that gave me, rounded off again to 3 digits, gave me that 146 angle. So maybe the moral of the story is do not what I did here. In other words, don't just start plugging into formulas without thinking, but definitely draw a picture at some point. I think it's perfectly okay to get to this point and then kind of say, let me draw a quick sketch to make sure that's correct and see if I don't need to add 180 to get the correct answer.